Trig substitution is very similar to U substitution in that what we want to do is to remove all of the x's and replace them with u's in U substitution to make the integration easier. Same thing is true here. We're going to use this triangle to substitute out all of the x's and just have an expression with theta. So if we arrange the triangle this way, the square root's on the bottom, x is here, hypotenuse is 3, so this would be a squared minus u squared. It's this setup here. Our angle is in the left-hand corner. So where these other ones are coming from, the sine function and the cosine, is just simply looking at the triangle. So the sine of theta is the opposite over the hypotenuse. And then we multiply both sides by 3. That is this expression here. So we can just use this to help us to identify what the u equation or what this variable x will be substituted out for. And then we can use this expression here to represent the square root. So, but where it comes from is, again, just looking at your triangle. Theta, we have the adjacent side over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. Multiply both sides by 3, and that gives us this representation for the square root, and this representation for x. And take the derivative of the x, and this will be our dx. So just substitute out those three pieces, dx, x, and then the square root here. Okay, so I took the dx and just slid it off to the side. So dx is here. The square root part is here. And then this is x squared. And we simplify. 3 cosine cancels out. That gives us 1 over 9 sine squared. And I just flip that. 1 over sine is cosecant. And 1 over sine squared is cosecant squared. So we integrate cosecant squared. And in the front of the book, we can look that up. And that is equal to negative tangent. And then now we need to substitute back in what the x's are. So if we go to the triangle up here, and then the cotangent will be the adjacent side over the hypotenuse. So here's the adjacent side over the hypotenuse, and then tack on plus c, and that's our answer.